Hello students, welcome to this session of this video. In this video we are going to discuss some questions in the chapter of classification of elements and periodicity of the properties. So question number 1 is, this is the first question. In this question that it has been asked, how many elements out of first 100 elements possess the 3D electrons? In the first 100 elements, how many elements having the 3D electrons? So first you have to know in which level the first 3D electrons is being filled, is going to be filled. First elements that you can understand that in the fourth period the element is scandium Sc. In this scandium, its atomic number is 21, and in this element the first 3D electrons enter, and means before that element, that is up to the period number 20, there is no 3D electrons. So out of 100 first 100 elements, 20 elements, that is up to calcium, that is 20 periodic number, there are no 3D electrons. So remaining will be the having the 3D electrons. So we can say that out of 111 elements, there is 20 elements do not have these 3D electrons. So remaining 80 elements will have that 3D electrons. So we can say this will be the D option is the right choice, right answer. That is 80 elements out of first 100 elements will have the 3D electrons. Now we are going to the question number 2. The second question, if a periodic table is prepared by subsiding the rules, that is above principle, Ohm's rules and Pauli's rules, Pauli exclusion rules, the number of elements in the fifth period will be, the option is giving 50, 80, 32 and 72. If we go by the normal, by obeying the rules, that is above principle, Ohm's rule, then it will be 18 elements. In the fifth period there is a 18 elements. But if it is not followed, then how many numbers? For that there will be the rules, that is 2n square. The number of element will be the 2n square, where n is the principal quantum number. Here it is the fifth period. The fifth period means 5. So 2 into 5 the whole square, that will be 50. 50 is the answer. You can calculate also that in n equal to 5, how many orbitals is available in that cell. That you can see it will have either 25 orbitals S, P, D, F and G. Total this orbital will be filled with the electrons, and accordingly there will be the number of elements in that period. So if we do not follow all those rules, then there will be the 50 elements. Okay? Which of the following elements with the atomic number Z equal to 25, Z equal to 30, Z equal to 80 and Z is atomic number here and Z 48 have the higher vapor pressure. So you can you have to know this element. Z equal to 25 means this is manganese. Manganese is a solid. Z equal to 30, that is zinc. This is also very solid. And Z equal to 48, it is cadmium. It is also solid. But Z equal to 80, mercury is liquid at the room temperature. So this will have the higher vapor pressure. In this question, it has been told that an element has 3 electrons in the 4th cell. The atomic number of the element, the choice is given 13, 21, 27 and 31. In the 4th cell means this element will belong to the 4th period. So that is the thing that you have to know. 4th cell means the elements will belong to the 4th period. So what is the last element in the 3rd period? That is your argon. So this inner core of this element will be argon. So electronic configuration of this element, electronic configuration of this element will be, its core is argon and at the valence shell is 4s2 3d1, because it has been told in the 4th cell there is 3 electrons. So we know what is the atomic number of argon? Argon atomic number is 18 plus 3, that will be the 21. The B is the correct answer. B is the correct answer and it is 21. Okay. So in this type of question you can answer, because sometimes it will be given as a 5th cell, sometimes it is given a 6th cell, and they have been given the atomic number of electrons in that valence shell. But you have to know the last element, that is the noble gas. The last element is the noble gas. You have to know its atomic number. Accordingly, you can able to make the electronic configuration and you will able to know the atomic number. Okay. So now the next question we are going to answer. That is the 5th question. Suppose orbital can accommodate 3 electrons, then number of elements in the 4th period will be, the option is given 12, 27, 18 and 30. Normally a orbital can accommodate 2 electrons. Suppose there is some, hypothetically we think that it will accommodate 3 electrons. Then what will be the answer? In the 4th period, we have to know, to answer for this question, we have to know in the 4th period which subcell is to be filled. In the 4th period, you have to fill it first the 4s, then you have to fill it the 3d, then you have to fill it the 4p. Okay. In the 4s, we know there is 1 orbital. In the 3d, we know there is a 5 orbital, and 4p there is a 3 orbital. So if we add this, it will come in around 9. So it is been told that 3 electrons, it can accommodate 3 electrons. So each orbital will accommodate 3 electrons, means 9 into 3, that will be 27. So this element will be number of elements in the 4th period. When the 3 electrons can accommodate by a orbital, then it will have the number of elements will be 27. Okay, this type of question will come and you have to answer accurately. Okay, so that is all for today's video. We will discuss later on different types of subject. Hope you enjoy this video. If you like this video, you can share this video to your friends, and I think that will be very helpful to you. Thank you very much.